Dear audience, let me introduce the results of our research on the topic Intelligent Systems for Socialization of Individuals with Shared Interests based on NLP, machine learning, and CO technologies. The research is performed by Taras Batiuk, Victoria Vysotska, Roman Holoshchuk, and Svitlana Holoshchuk. We are from Lviv Polytechnic National University. Developing an intelligent system for the socialization of individuals is one of the critical tasks of modern social communication. That's why the main goal of our research is to create an intelligent system for the socialization of individuals that uses CEO technologies and machine learning methods. The third goal includes the following objectives: to specify the intelligent system structure by using IDEF and IDEF3 diagrams, to construct the hierarchy of the system processes by using a tree structure, to implement neural networks for identifying a human face on the photos, and to create an algorithm for analyzing and comparing user information. To achieve the goal of our research, we analyze the following technologies and applications. They are Twitter, Instagram, Tinder, Badu, chat-out programs, Levenshtein, and fuzzy search algorithm. The main aim and aspects of the system's functioning are formulated using the goal tree to describe the intelligent system. In this case, the system is regarded as an intelligent system for the socialization of individuals by common interests. On the slide, you can see a goal tree of the intelligent system containing 4 levels of hierarchy. And the next step is to prioritize hierarchical elements. After constructing the goal tree and related works, the system functions were further specified, and IDEFO functional diagrams are selected to detail the system structure. First of all, to generalize the main functions of the created intelligent system, a contextual diagram is created. It consists of the main input and output data and primary data for displaying mechanisms and controls. Input data includes a user login, user password, database, user photos, and user requests. Initial aspects include user socialization and an updated database. Then the decomposition is performed and a hierarchy of processes at the lower levels of the system is constructed. In addition, most of the intelligent system processes are specified using workflow diagrams. A tree-like display structure is used to display a transparent form of the intelligent system and the order of processes, since it is the easiest way to represent a clear hierarchy of system elements. The primary root process of an intelligent strategy is search for relevant users, as this is the most generalized explanation of all the processes that occur during the system's operation. The hierarchy of processes is shown here on the slide. We use an IDE environment developed by Microsoft Visual Studio to write an intelligent system for socializing individuals by common interests. Visual Studio also has a free version, which is entirely sufficient for most of the task set. This development environment is convenient and easy to use and provides many different opportunities for writing code. It easily debugs a program by using code execution breakpoints. A screenshot of the Visual Studio program and its main elements you can see here. Unique requirements are also used to write the client part of the program. In this case, there is already a lot to choose from, and they are Visual Studio Code, Sublime Text, brackets, and other application programs, which are the most often used ones for developing client software products. In our case, Visual Studio Code is chosen as the Microsoft created this development environment because it is easily interacting and very similar to other company products. On the slide, you can see the screenshot of the Visual Studio Code program, which we used in our research. All data of intelligent system is stored in tables in a relational database, and all available information is linked to each other using relationship. A diagram of the current database is shown on this slide. First of all, let's explain the key table of the database. It includes the slots users, messages, likes, and photos. The user slot represents the current user of the system. The photos table contains all the main properties of user's photo in the intelligent system. The messages table contains all the basic properties of messages sent by users of the intelligent system. And the likes table contains the IDs of users who put likes, namely liker ID, a unique identifier of the user who likes, liker ID, and likee ID, a unique identifier of the user who is selected in the system. The analysis and formation of similar user BIPs are implemented using fuzzy search algorithm, the Levenshtein algorithm, and the noisy channel model, which made it possible to maximize the user selection processes automation and optimize the time spent in this process. The block diagrams of these algorithms are presented on our slide. So, N-gram algorithm, sample expansion algorithm, and Levenshtein algorithm. The control example shows the main functions and work of the created intelligent system. Here you can see the generated list of users using text processing algorithm and sorted in descending order by the percentage of user similarity and the use of filters to search in an already generated list. After receiving the implemented intelligent system, a statistical analysis of two system parameters was carried out, namely comparing the speed of user sample formation and the accuracy of the obtained percentage ratio. The combination of the Levenshtein algorithm, N-grams, sample extension, noisy channel model, and the standard Levenshtein algorithm is most often used in similar systems for the socialization of individuals. Being implemented, they are respectively compared. The diagram, which you can see, demonstrates that the combination of algorithms is more efficient and accurate by about 25–30%, pairing with the usual Levenshtein one. The speed of forming a sample of users is analyzed. We selected 12 users of the system and developed an example using a combination of algorithm and the standard Levenshtein algorithm. The resulting diagram is shown on our slide, and it can be concluded that the combination of algorithms implemented in the system makes the sample about 10 times faster than the standard Levenshtein algorithm. Now let's move to our conclusions. In our time, the socialization of individuals according to shared interests is an essential process, since most people try to simplify and automate the main life processes, which usually take up a lot of free time. We investigated the main algorithms that play an essential role in social networks and various user interaction systems. So, the intelligent system structure was also specified using IDF of O and IDEF3 diagrams and the hierarchy of system processes was constructed using a tree structure. Two neural networks were implemented, convolutional and Siamese, which allowed us to search for a human face in the photos that the user uploads and compare the found face with the available faces in the database. An algorithm for analyzing and comparing user information was created using fuzzy search algorithm, the Levenshtein algorithm, and the noisy channel model. We achieved our goals and objectives in our work, but there are still many things that can be improved inside the created intelligent system. So it makes room for other further investigation and research. Thank you very much for your attention. We'll be happy to answer any questions.